Hello everyone. I've been playing this simulation called Space Engine. It's been quite interesting and intriguing just looking at different things around the universe. And I discovered something very intriguing about this. I think this is close to real time. Yep, okay, there we go. So now we're right on real time. Everything is moving just as if we were on a satellite 10,369 kilometers above the Earth looking down. So that's what this distance up here, if you see where the cursor is, this is telling us how far the camera is from the surface of the Earth. And what's interesting is that this program actually models a certain behavior about spheres and the distance camera is from them and what is visible on the screen. Namely, it shows a limited portion of the hemisphere based on your distance away from the surface. Now that sounds kind of complicated, but what it means is that the closer you are, the less of the surrounding area you'll be able to see. I mean, that makes perfect sense. If we zoom in here, so this is Colorado here. We zoom in here, we can see this be Colorado Springs, Denver, Pueblo down here. I don't know how realistic these particular graphics are in terms of the resolution and things like that, but on a whole, this looks pretty cool. And if we zoom out, we can see more of the Earth. And here we can see pretty much all of the western U.S., most of the central U.S. over here. We've got the Michigan Peninsula over here, Great Lakes over here, things like that. Down here we can tell there's Mexico, things like that. But you can't see New York in this view yet. We zoom out a little bit more, and now we can see all of the lower 48. We can zoom out a little bit further, see bits of Canada. Up here's Alaska, and over there somewhere is going to be Hawaii. What is very interesting, again, with the modeling of the geometry that's going on, is I've recently seen some people online who are flat earthers who have given pictures of different satellite images of the Earth taken by NASA. And it shows different sizes of things such as North America. And the claim is that NASA, in their conspiracies, can't get consistent. They don't even know what the correct size of the continents are relative to the sphere of the Earth. Now, I just want you to look at this really quick and see, this is the size of the United States when we are at almost 11,000 kilometers above the surface. As we move out, you can see, relative to the rest of the sphere, this actually shrinks. And we can see more from the edges. We can now see South America down here. We get out enough, we can start seeing Europe coming in to the scene here. The farther back we go, the smaller this appears, not just because the whole Earth is getting smaller, but relative to the rest of the sphere that is visible. And that is because the farther away you get, the more of the hemisphere you're able to view at once. Up to a maximum at, if you could get to an infinite distance away, it would be exactly 50% of the sphere that you can see. Now, obviously, physically, nobody can get that far away. So we're going to be at 49.999%. But here we can see it happens fairly quickly. You get quite a big chunk of it. We're less than 50,000 kilometers away from the Earth right now. And we can see a large chunk of the Earth from here. And if we go back even further, the edges just kind of fill out a little bit more. Again, it gets smaller, so it makes it harder to see details over the edge. But let's zoom back in here really quick and watch as the edges will fade over the horizon and they will start to disappear. Especially here you can see Europe, because the lights will eventually go until they are behind the horizon and they disappear. Now there we go. Now it's completely, we're on the horizon. This will give you a different view of the size of the relative size of the continents than if we zoom back out, we get from that view. Because again, we see more of South America, for example, here, and as we come in, South America starts dropping off. Our brains are interpreting this as the whole ball. We think we're seeing 50% of the hemisphere here. So it looks weird to us. As we zoom out, we see more. it doesn't look like we're seeing more surface area of it, but we actually are. You can replicate this to some extent using just a globe on Earth if you want to use a camera away from a globe. If you get it just a couple of feet away, say 2 to 3 feet away, and take a picture, and then you move back 10 feet and take a picture, you will see that there is more surface area visible the farther away you are. Even though it will be smaller in size, so it's harder to make out things, you will see around the corners. Now, most of the balls that we deal with are fairly small. We play with like baseballs and basketballs and things of that nature. We don't have giant balls like the Earth is. It's a huge, the radius there is many thousands of kilometers. So we don't have that experience of seeing something on this scale, but we can replicate it up close. And if you use a globe and take some pictures, you can even just kind of close one eye, look with one eye up close, see what's visible, and then slowly pull the globe away from you and see the edges kind of look like they're wrapping around, and you're seeing more around the edges. So all that to say, the pictures that show North America looking this size relative to other pictures that, when we zoom in, I'll speed up a little bit, we might see a different satellite that shows North America looking this big. And you might say, hey, why can't you decide on how big these continents really are? The reality is the continent size is not changing. What is changing is the amount that you're seeing around the horizon. The amount of the surface area of the sphere that is visible to you is what is changing. And so our brains are interpreting it, making it look like here the continent is bigger relative to the size of the Earth as a whole, as opposed to when we zoom out. Now it looks smaller relative to the size of everything on Earth. Anyway, thank you guys for watching, and if you've made it this far, I hope that you enjoyed this. If you are somebody who does believe in the flat Earth theory, then you have my pity. You know, if you want to debate it in the comments, do whatever, because you're going to anyway. So I hope everybody has a wonderful day. God bless.